All right, Brand class, today we are going to be finding the area, the space inside polygons. Polygons are just closed figures with any number of sides. This figure has 5 sides. So what do we need to know to be able to find the area of this? Well, let's go to what you already know. You already know how to find the area of a rectangle. You just multiply the length times the width. A parallelogram, you multiply the base times the height, and a triangle, you multiply the base times the height, and then multiply that by 2, or divide it in half. So since you know this already, this is actually all you need to know. If you already know how to find the area of these figures, then you can find the area of something like this. All you have to do is divide this figure, this shape, into shapes you already know how to find the area of. So we're not going to be able to do it in one step. We're going to have to divide it. So let's think, how would you divide this into rectangles, parallelograms, and triangles? Go ahead and pause the video, think about it, and then I'll come back with some solutions. All right, so first, one way you can look at this is, let's see, I can make, if I divide it here, then I've got a triangle here. Let me use a thicker marker. So something like that, and then I can just do another triangle over here, and then this gives me a rectangle here, and then I've got another triangle here. So I've divided it into 4 shapes, then I can just find the area of each of these shapes and find the area of the entire figure. Of course, there are other ways to do this. I have another figure down here, and I do see that if I do something like this and make a triangle here, I can also make a parallelogram here. Maybe you saw that. And then I have this triangle. That's only 3 figures. I can find the area of those. So there are a number of ways you could do it. I could go to the next page, maybe. And let's see, what if I did something like this? Could I divide it in half like that? Well, that's a trapezoid. Let's see if I did that there. That's a triangle, and then there's a rectangle, there's a triangle. Yeah, this doesn't really help that much, right? Like, now I have 1, 2, 3, 4, 5, 6 figures I have to find the area of. It'll work, but it's just more work than, generally mathematicians like to be efficient and save time and try to find the fewest figures possible. So let's do this one. So I have a parallelogram, and we know the area of a parallelogram is base times the height. So this base from here to here, it's 1, 2, 3, 4 is the base, and then the height has to be perpendicular to the base. So I'm saying that it would be the height. I see that's 2. So 4 times 2, so I see 8 square units there. Now this triangle, this base here is 2, and then the height has to be perpendicular to that, and then this is also 2. So this here would be 2 times 2, which is 4, but I have to find half of that. So half of 4 is 2. So I think this is 2 units here, 8 units there, and now how about this big triangle? Now, if I use this as the base, that could be the height, but I don't really know how long each of these are because they're not sitting right on these grid lines. So I think I'm going to look at it this way and use this long side as the base here. 1, 2, 3, 4, 5, 6. 6 there. And then the height is perpendicular to this all the way up here, and that's 1, 2, 3 units. 6 times 3, let's see, 6 times 3 is 18. Then I need to find half of that. Half of 18 is 9. So let me turn this over so I've got them all together. So I see 9 there. So now I know the areas of each of these figures. I just need to add them together. 2 plus 8 plus 9 8 plus 9 is 17, plus 2 is 19. So the area of the entire figure would be 19 square units. So really you have all you need to be able to find the area of one of these shapes. You could split it this way, you could split it this way. You just have to split the shape into figures that you already know how to find the area of. So now you're good to go, but keep watching if you want one more way to do it, if you want to find one more way. I have one more blank here, and some students think about it this way. They think that this figure is covering the large majority of a rectangle here. So if I find the area of this rectangle, go back to my thing marker, it is 1, 2, 3, 4, 5, 6. And by 1, 2, 3, 4, 5. So the area of the rectangle is 6 times 5 equals 30 square units. So now, if I know that the entire rectangle is 30, I can subtract that spot in here to find what the area is of that shape. Sorry, someone was at my door. So as I was saying, if you can just figure out how much is in these white spaces outside of this figure, you could subtract the white spaces from this 30 square units, that is in the entire rectangle, and then what you'd have left is what's in that shape, the gray area. And as you can see, I've got 4 triangles here. These triangles are equivalent, which makes it nice. So this triangle is 3 by 3, and so is that one. So 3 times 3 is 9, and half of 9 is 4.5. So that's 4.5, and that is 4.5. And together those actually would be 9, right? These triangles here, I see this is 2, and that's 1. So 2 times 1 is 2. Half of 2 is 1, so that's an area of 1, and that's an area of 1. So if we get 1 plus 1 plus 4.5 plus 4.5. These are 9. These are 2. 2 plus 9 is 11. And 30 square units for the entire rectangle minus 11 units for the white portion equals 19 units for the gray. So just another way to look at this situation to get the same area. Here we did it by adding the portions of the gray together, and here we did it by subtracting the portions of the white from a rectangle that surrounded the entire shape. All right, you know enough to be successful.